In this video, I am going to cover the Jatco CVT transmission. CVT stands for Continuously Variable Transmission, and Jatco stands for Japanese Automatic Transmission Company. Jatco is owned by Nissan, and they're used in a wide range of vehicles, everything from Nissans, pretty much every 2007 to current front-wheel drive Nissan uses a Jatco CVT, but they're also used in things like Jeep vehicles, they're used in Suzukis and Mitsubishis, and a wide range of vehicles. They'll sell to just about anybody. So this one right here came from Chrysler. I believe it came out of a Jeep Compass or a Patriot, one of those fine vehicles. And we're going to go through and completely disassemble this thing and reassemble it just as if you would do if you were overhauling it. First, I want to point out a few things on the outside of this. This area right here is where the torque converter would live. You can see I could spin the input shaft. It spins freely. Not hearing any chunks and pieces and parts falling. That's a good sign. Now on the top of this transmission, I've got the shift selector. This is what's going to be allowing you to shift between the different ranges, park, reverse, drive, and so forth. This is the actual range sensor. So this sensor here will feed information to the TCM or PCM on what range is selected. So that's good to know. This right here is my output speed sensor, and it measures right off of this gear that we're going to see when we take it apart. So one thing you'll note here is that there are these two thin washers between the sensor and the front bell housing area. You want to make sure that those washers end up back in there when you assemble it, because that spaces this speed gear out far enough to the point where it's not going to contact anything. If you forget to put those in there, you're going to drive the sensor in towards that gear, you're going to grind it up and create a mess in the transmission. It's going to be bad. This is some identification marks here. This is 1XW05, I think, maybe. I don't know. And then some other etchings. Continuing on to spin this thing around. Behind this cover right here is where our pulleys are going to be. This is a pass-through connector. It allows the harness from the vehicle to find its way into the transmission to operate the solenoids and so forth. This plate right here, you might find different configurations on the transmissions you pull apart. Some of them have an extra set of lines, and there'll be what's called a warmer or a cooler, small little mini radiator, if you will, where they'll bring engine coolant up to that little cooler assembly and bring it back. Usually that preheats the fluid. The engine coolant will warm up quicker than the transmission fluid, and then they'll heat it up. This one right here just has a flat plate because it's going to deliver the transmission fluid to an air-to-oil cooler and deliver it right back. So this is a simpler setup. It's not like the others are complicated. On this side of the transmission, we've got all these ports. And these ports right here are for pressure testing. So if you actually have to go through and hook a gauge up to it and verify pressures, that's where you'll do that at. I also have another sensor right here. That's going to be the primary sensor, and it'll measure off of the primary pulley. So I've got basically the electronics covered on the outside, got some pressure ports, torque converter lives in there. I'm going to go ahead and take these external parts off first, because if we're rolling this thing around on the bench, we don't want to take the chance of snapping a range sensor off or breaking the pass-through connector or something like that. So I'm going to go ahead and take advantage of the fact that everything's up here and pull these top pieces off, kind of tuck them out of the way. I'll go ahead and lay those back on there. Hopefully that'll remind me. Behind this plate, there's this cooler filter right here. And you can inspect between the pleats of this filter to see what kind of material this transmission's been collecting. The fluid that gets caught in here would have pretty much come from the torque converter. So if your torque converter was coming apart, you would definitely see this loaded up. At this point, I've got all the fragile components removed from the outside of the transmission case. I'm going to roll this around and get the valve body, aiming towards the top. Ta-da! Now that I got the pan off here, I can go through and remove this valve body. If you take a look at how I have this set up here, I've got some of these bolts have a blue paint on top of them. Those are the bolts that you're going to take out first, and that'll allow you to pull this valve body out completely without having to completely disassemble the valve body at this point. Usually when I loosen up valve body bolts, I like to go from the outside and spiral my way in towards the middle. Now, we're going to pull the filter off first because underneath the filter there's a couple bolts that we also have to get out. It's a pretty simple filter, it's just got a screen in it. Doesn't have any paper or anything like that. These are the two bolts that I need to remove. It comes with that bracket. Before I pull this valve body out, I'm also going to need to take out this nut that retains this linkage that moves my manual valve. This CVT has what's called a ratio control valve. It's the valve that lives in this bore right here. And it's controlled by this ratio control motor. And this side right here links into the pulley assembly, which is right there, that little pin on that pulley assembly, because this little guide kind of follows along with the primary pulley. And so that way the pulley position is going to extend over to that pin. And that pin is going to be hooked up to this linkage. That linkage is hooked up to this valve, and this valve is also hooked up kind of like a seesaw. It's hooked up to this ratio control motor. So this ratio control motor is in direct control of the ratio, because as this changes its ratio, as this ratio control motor goes forward and back, it changes the position of this valve, which either allows fluid to drain or fill, fluid pressure, into the primary pulley, and it waits for basically the pulley to react. And once it reacts, it goes to kind of a steady state. To kind of keep things in position, we can put a piece of welding wire that'll end up going through this hole. That's actually how you install this thing. You have that welding wire there, and it holds this link in that position, so that way when you go to drop it in, it's actually in the right spot. This seal right here fits between the valve body and the transmission case, and it seals off the passage that ends up filling this reverse clutch assembly. So you don't want to lose that. Obviously a new one comes in the kit, but at the same time, it's always a good idea to keep your parts. Okay, now that I've taken this valve body off, that was kind of the second step. First step is taking all these fragile electronic components off around the outside. And then the second step is taking this valve body off. The third step is we're going to remove this bell housing. And when we take it off, we're going to take out the gears, the final drive, the transfer gears. We're going to take out the clutches, the input shaft, the oil pump, all that stuff. And then fourth step, we're going to go through and take off this cover on the back. And that houses our pulleys. But we want to do this in order. We want to do the electronics, valve body, bell housing stuff, and then the pulley end cover. And then when we go back together, we'll do it in the opposite order. You can see the difference in the lengths of bolts. You just have this extra 1/4 inch on some of them. Most of them are threaded all the way. There's a few that are, well, 5 on the bell housing side that have that extra 1/4 inch of shoulder. It's pretty easy to tell because if you put a normal size one in where a long one goes, it's not sticking out very far. If you put a long one in where a short one goes, it's sticking out too far. If we've got all the bolts out, we should be able to pull this case cover off. This one's been apart before. Obviously, you're going to have sealant on there if it's never been apart before, so you might need to get into some of these little pry points to kind of break it loose. Well, there's a dowel pin over here that you could gain access to tap on. The other one here is kind of blind, but this one will come apart easy because it's been apart before, so long as I got all the bolts out. As far as the bell housing is concerned, really I only have this transfer tube right here that kind of delivers oil to these bearings. Other than that, I can put this bell housing off to the side. Now we see all these gears. These are mainly like final drive. This right here is the pulley output. This is a transfer gear. On the bottom of the transfer gear, I've got the pinion gear driving the final drive gear. Now there is quite a bit of shrouding on this transmission, and it's for deflecting oil and kind of keeping it all in the right spot. So it's important that the shrouds go back the way they're supposed to. This is something that commonly gets misplaced. This pin right here goes through and kind of keeps this shift shaft into place. See how that doesn't move much? If I take the pin out, flops around like crazy. So there's a little groove cut into the shaft, and you want to obviously not lose that. If you tip the transmission over, there's a good chance that this is going to lay on the bench, and you're going to be like, where'd this go? Well, that's where it goes. Basically a 10, 12, and 14 millimeter will do, and a 6 millimeter Allen will do pretty much everything in this transmission. Now we're going to take this oil pump off. In order to do that, I'm going to spread open, right in this window of this gear, there's a snap ring, and I can open that up, and it allows me to pull the bearing and the sprocket out. Here are those parts right there. Notice the dark link, it's not on the other side. So that would be an identifier to help you make sure, when you make sure you put it back together, make sure that dark link is facing up. You also notice that there's a thrust washer up against this for this gear, or the sprocket, the drive sprocket, but there isn't one on the top. It's because the torque converter is actually going to lug in and support that sprocket, so they don't need a thrust washer on this side. Just the side that goes towards the support assembly. I'm going to go ahead and pull the rest of my support bolts out. Before I pull the support out, I'm going to go ahead and roll this O-ring off of the input shaft. That's for the torque converter clutch. You might be able to slide it over, but I don't want to take a chance of cutting it. So there's my support. If you notice on the back of the support, I've got these Teflon seals. They're one-piece Teflon seals, so you want to inspect those. Make sure they're in good shape. You have a bushing that lives in the front, you want to make sure it's in good shape. The stator splines, you want to make sure those are in good shape. And obviously if you have to replace these seals, you have to use a sizer because they are one piece. While I'm here, I'm going to go ahead and pull out this detent spring. There's a little tab that lines up with the hole in the case. And I'm going to go ahead and pull these 3 pump bolts out. That takes a 6 millimeter. At this point, you can't take the pump out yet. There's actually a bolt underneath, kind of like a hidden bolt. This bolt, as well as some of the others, actually have an O-ring in there, kind of an O-ring seal. So in the kit, you're going to get new O-rings. You're going to want to peel those back and replace those. I can pull the oil pump out now. We'll go through the oil pump separately. Also notice you've got a pump seal right here. That's going to seal off the oil pump to the transmission case. So don't lose that. Your kit is obviously going to come with a new one, but it's always good to keep your stuff. Now I'm going to go ahead and pull this input shaft out. On the input shaft, on the inside of the input shaft, I've got my forward clutch. It's located down there, and it's retained by this. There's a forward clutch. We actually have to take, in order to get to it, we take this internal gear out. So there's an internal gear here, and then the forward clutch underneath it. The forward clutch, when it applies, it's going to grab onto this hub assembly right here. And you're going to notice that hub assembly's got big old sun gear on the other side of it. Well, it's in forward, when the forward clutch applies, it grabs onto these outer lugs. And if you notice on the sun gear assembly on the inside here, there's a set of splines. That spline will grab onto this set of splines right here, and that is going to directly drive our pulleys. So when we engage the forward clutch, we actually drive this hub, which drives the primary pulley. Because the reason why they have that sun gear there is because when we're in reverse, this reverse clutch applies. And if you remember the input shaft here, not only did it have the forward clutch, but had this internal gear. So the reverse clutch is going to hold when that clutch applies. The internal gear is going to be input, been in a slight reverse overdrive. Be a medium-sized gear driving a small gear. It's overdrive. Okay, we'll put that stuff off to the side for now. So here's my sun gear. This is that carrier. It just lifts out of there also. You do want to pay attention. We've got Torrington bearings and so forth. I've got the reverse clutch, the reverse piston, the reverse piston return spring. I'll go ahead and pull all those out, and then I'm pretty much going to be done with the bell housing. We'll get ready to pull the end cover off where the pulleys are. Thicker snap ring, retaining that reverse clutch assembly. On the reverse clutch assembly, I've got a thick backing plate. I go friction steel, all the way down to this dished plate. And the dish is facing up, just like a dinner dish would be facing up. This snap ring in here is retaining the reverse piston and the reverse piston return spring. There is tension on it. It's not a whole bunch of tension, but there's a little bit of tension on it. So when you go to peel it off, it might help to push down on the piston a little bit as you're taking it apart. But it's not going to shoot up at you and hit you in the face or anything like that. But I can't promise anything. This plate right here, this thin plate lives on top of this return spring assembly. So this plate assembly just reinforces the top of this return spring, and it keeps the return spring from deflecting too much. At this point, I'm going to go ahead and pull my reverse piston out. And if it doesn't want to come out, I can blow air pressure into this passage right there through the valve body opening, and that will pop this out. I've had this apart enough times, I think I can just reach in there and grab it. There it is. This is a molded piston. One piece steel with rubber molded onto it, kind of melted to it, adhered to it. So you'll have to replace this when you overhaul it. Okay, now I'm done with all these components. I'm going to flip this transmission over. And I'm going to go ahead and pull all these bolts out. Well, not all of them. I'm going to pull all the outside bolts out. I'm going to leave these 6 inner bolts out that kind of form a triangle shape here. The reason why I do that is because that's what's retaining the bearings that are holding my pulleys in place. So if I keep those in there, and I tip this transmission over and kind of finagle it, I can get this pulley assembly out. But if I take these out first, or at the same time as these others, and the plate starts coming off, the pulleys can get cocked, and then I can fight it a little bit. I'm sure it'd work either way, but this is just the way I'm doing it. These two right here take a bolt that has a shoulder on it. And then of course this one's really long, so that's kind of obvious. Other than that, all the others are the same length. Now that I got all these bolts out, I can try to pry up on it a little bit to kind of break any seal, any bond. You can see that kind of opened up already on me. Sometimes this shaft wants to fight you. It has to stay with the end cover when you take it out. So if it tries to grab up in here when you're lifting it out and this does not want to drop and it's kind of seems like that's fighting you, it's because this shaft is lifting out with the case as you're trying to pull it up. You got to push this back down using something. But we'll see if it comes out without too much of a fight. See, that's exactly what I'm fighting. All right, with a little bit of a battle, it came out. This little O-ring seal lives between the center case and this little part right here. It's something that'd be pretty easy to forget to put on. And obviously it's important because you want to make sure that there is a seal between that and this, or else we're going to have a hard time getting these pulleys to operate properly. So I don't damage it, I'm going to go ahead and pull this pin out. And you don't want to break or tip this over, bend this pin, or break this aluminum follower. There's a spring that goes underneath it right here. So that spring keeps tension on this piece and pushes it up against the bottom of this pulley sheave, and it's going to follow along with this sheave as it changes ratios. And if you remember, that's the pin that operates up against the ratio control valve in the valve body. So yeah, you want to make sure you don't damage any of this stuff. Now I will go through and pull those 6 bolts off. And if you take a look what's happening here, I've got this pulley assembly sitting there. I got my push belt located in between the two. This secondary pulley, this output pulley, it's the one that has spring force on it. So it's actually squeezing these sheaves together, putting tension on that belt. If you take this apart, it's going to kind of, not with force, but it's going to move together. It's going to kind of move these two pulleys together, and that's what makes it difficult getting those pulleys into this case, and it also makes it a little difficult pulling it out. So to make life a little easier, we're going to go ahead and use a Robert Bateman seal aftermarket trick and use some PVC pipes to help support this. So this will allow me to kind of situate this thing fairly even. Now I got this end cover sitting on my PVC pipes. I can go ahead and take these 6 bolts out. I'll gingerly tap this cover off and I'll have my pulley sitting there. Using these PVC pipes obviously isn't completely necessary. It just makes it a little bit easier to handle it. All 6 of these bolts have those O-rings on them, so you definitely want to replace those. I've got a little selective shim, which you really shouldn't have to worry about unless you're swapping end covers or pulleys or something like that. So at this point, I've got the end cover off. I need to get to my belt, need to take the belt off, and I need to take my pulleys apart. So that's the next step, next phase. So as of right now, I haven't really needed that many special tools, or really any, unless you call PVC pipes special tools. This tool right here is going to help me pull these sheaves open. If you remember, I said that there's a big spring holding this sheave assembly together. Well, I need some kind of a puller to help spread this open. I could twist and finagle and get this belt off of there, but I don't want to cause any damage. You don't want to kink or twist these belts too much. This puller assembly, you can actually buy these on Amazon. Lock model TJ1. It's really nice. And the idea behind it is that this piece here, as you tighten it up, it squeezes these jaws together. And it's got a real fine edge on here that grabs underneath that pulley, right underneath the small lip that I'll have on the sheave. This side is actually sheared off. The students got a little carried away with that, I guess. But it'll still work. I need to remachine that lip there though, because there's a greater chance of it slipping off, obviously. So I'll tighten this up pretty tight so it really pinches on this pulley, and then I'll use an impact and kind of blast that. Let me go ahead and put earmuffs on though. My ears ring enough as it is. One of the things to think about here is the danger zones. Obviously you don't want to put your hands around these belts, because if this slid off and this squeezed together and it pulled in and your fingers are in the wrong spot, probably chop them right off. I mean, that wouldn't be good. I don't think it's a good idea to put your hands in here either. When we go to pull this assembly apart, I will use this puller to pop this off because there's a press fit here. It comes off with enough force that I put leather gloves in there to kind of prevent this piston from getting damaged. I got some old welding gloves I put in there. So just kind of be aware. All right, so another thing to think about is before we get too carried away disassembling all of this stuff is this belt. It is directional. I don't want to get this going. I can't flip it around and expect it to work. So what a lot of people do is they'll take a zip tie or two, zip tie it and leave the end facing up so that way they know that's the direction that's going to be when they go to reassemble it. Another reason why you want to use a zip tie is because these little steel straps that are on either side here, they're the only things that are really keeping all these links, these individual links together. So if I were to pull this out, see how that comes out? If I did that to the other side, these would just probably fall apart. These links have, as a matter of fact, you do want to slide these apart, not take the elements apart, but slide the bands out, because you want to make sure there's none of them that are broken. That is actually an issue that could happen to these units. And when you take this apart, when you slide these out, you'll know if one's bent, or you'll know if one's broken because it'll usually coil out. But another thing about these push belts is if you look at these little elements, they're actually shaped like the letter P. That's kind of backwards. Let me flip it over. So the P's are like all in a line, right? A bunch of people with their heads sticking out. Well, the rotation is in the direction of the direction that the P's are facing, or the faces are facing, human heads. You can see that there's a rotation. They put an arrow on it. So they want the rotation in the direction of those P's. And this is my input pulley. It's going to be rotating clockwise. That's probably an optical illusion there, isn't it? So you want, the engine's gonna rotate clockwise, so the piece has to, so you can figure it out. It's just probably best off just marking it, identifying it. Then it won't be a question, right? You'll know what it is. For the sake of this video, we're gonna go ahead and take out this primary pulley and then put it back together. The secondary is pretty much the same. Matter of fact, it's easier because you don't have to deal with that preload spring. But first thing I have to do is take this puller off. All right, safety glove or ear protection. I'm going to go ahead and take this nut that's retaining this gear and this bearing. I'm going to go ahead and blast that off with the impact as well. I have to use a puller to pull this bearing and this gear off, so I'll need a 2-jaw puller. As you can see, it takes a bit of force to get this off, so we'll end up having to use a hydraulic press to put that back on. If you notice, when I press this gear off and this bearing, there's a shoulder on this gear. That shoulder faces towards the bearing. And this is also kind of the inner bearing race is split. It leaves the other half on the actual secondary pulley. So just pay attention to the way it came apart so that way you can put it back together the same way. At this point, I like to consider this a loaded weapon because there's a spring and there's nothing retaining it. So go ahead and thread this on a few turns or maybe all the way. And just in case. I mean, I doubt anything will happen because there's a decent amount of a press fit that exists on these parts, but I'd hate to see someone get hurt over something silly like that, especially considering usually your face is right over the top of this while you're working. The next thing we're going to do is overcome this press fit, and even this bearing race here has got kind of a press fit, by putting our big fancy puller on there and pulling up on it again, and it's going to slide that up and then pop off. It'll come out with some force. Probably scare you a little bit. You might end up peeing your pants a little bit, but hopefully not. Okay, so I got these welding gloves ready to go here in a second. What I'm going to do is I'm going to raise this piston up, and then once it's up about a 1/4 inch or so, I'm going to tap on this outer piston. And the reason why I do that is because there's a snap ring up here. And if I take that snap ring off now, when this thing comes up, all that stuff usually pops up at once. It makes life a little easier and a little less scary. You hear that sound, that little pop sound, that's the piston going down just a little bit. You just need the piston to go down just a little bit to help relieve the tension on that spring. So there's the snap ring. Remember to go ahead and put your gloves in there, so that way when this stuff all pops up, it doesn't damage the pulleys. You probably heard and saw all that stuff pop up there. Take the nut off, the other half of my washer, and here's this is kind of like a retainer and the CVT piston. The return spring or the preload spring. This assembly obviously moves up and down, and we've got the spring assembly and hydraulic pressure kind of keeping this squeezed together. The only thing that's going to allow this to move up is if the primary pulley, the input pulley assembly, has more pressure and it's trying to squeeze together. Well, that's going to force this one to open up because the belt can't stretch or grow, so that's what happens. Now, when I go take this apart and I lift this off, there's little ball bearings in here that this glides on. And you definitely, there's a reason why we're taking it apart, not only to inspect seals and so forth, clean it up, but we also have to address these ball bearings in there. So I'm going to lift this up. You don't want to go, you just want to go straight up with it. You don't want to go up and down. You might even have to tip it over and nudge it. There's a couple of them. Look at that, they all stayed in there. That was magical. So those ball bearings, they ride in that little groove. And you might, there's 3 grooves, so you might have anywhere between 12, 9, or maybe only 6 of these check balls total. So in this case, I've got 12. So I've got 3 groupings of 4. So there's actually just, so each of those 3 grooves is going to have 4 check balls. And some companies replace these ball bearings with a single roller bearing. And if you use those single roller bearing setups, you want to match them up. So if you've got 4 of them, 4 of these, you want to match up the long roller. If you've got 3, they give you a medium-sized roller. And if they have 2, they've got a small roller. So you got to make sure you have the overall the right length. So now that I've got this apart, I would go through and inspect and clean. I'd look at these grooves that the roller bearing rides into. If I replace I either want to replace these roller bearings or I want to go in with a roller itself, a pin, instead of a bearing. If we've got material buildup on this pulley half here, you can't actually polish that off. You could spin this up on a lathe and put some sandpaper up against that. Usually that, what looks like scoring on there is actually buildup of material, either buildup from the belt or chain, whatever it is that's driving up against this, or maybe even material from like the torque converter and so forth that's coming apart and getting trapped and embedded on there. So a lot of these pulleys can be cleaned up. And even if you've got a little bit of damage in these grooves, if you're not going back with a check ball and going back with a pin or roller bearing, as long as that all slides up and down fine, you can actually get away with that. So now when I go to assemble this, so we'll pull this snap ring off. One thing about these snap rings, they have this little dimple, this little raised spot right there. You can see that? Almost looks like it was damaged. That little raised spot lives in this little notch, this little cutout right there. That little raised spot lives in that little cutout. So when you go back together, there's only really one way it can go. Precision fit. Matter of fact, the fluid pressure that fills into this cavity here, it doesn't even have a seal that it rides around. You know, you can see I've got these snap rings and just basically a tight precision fit that exists between these 2 halves. So that'll slide down like that. I'm going to go ahead and put these ball bearings back in place. So I'll lay 3 of them in there. Then I'll take my screwdriver and push them down just a little bit. Lay 3 more in there. If you want to avoid losing and chasing check balls if you drop them, get a stainless steel top with the wood underneath it. They don't bounce. Isn't that crazy? No bouncing. Okay, at this point I've got all my roller bearings in there. I'm going to lift this up. I don't want to go too high, but once I get it up high enough to expose my snap ring groove, I can go ahead and put my snap ring back in there, and then this is assembled. Looking good, Billy Ray. Feeling good, Lewis. I'll go ahead and put this back together, and this will involve the arbor press, which is always fun. And what I'm going to do is I'll put, oh yeah, and by the way, obviously you'd want to change this seal right there. This has got one of those L-shaped Teflon seals, and it's going to ride on this inner surface. The inner surface does have kind of a chamfer, so it'll guide that in. I like to fill this groove right here up with Transgel and kind of embed that seal into there. And so that way when I go together with it, there's less chance that I'll nick that seal. Okay, so I'm going to go ahead and press this assembly down using the arbor press. And then when I'm done, I'm going to carry over there with me this nut as protection, just kind of to thread it on in case it decides to come loose on me. So let's go over to arbor press. It's guiding in there nice. And it'll make a pop sound, but don't freak out about that because there is a press fit, so it will kind of pop over the shaft. Okay, I think I'm on. At this point it is a loaded weapon, so I will put this nut on there for safety. Also avoid putting your hands anywhere between that in case it decides to come up, so carry it from underneath. The arbor press is going to be a little much to try to get this bearing race, the gear, and the bearing on. So we'll go over to the reel press to do that. Place our washer down in there, our bearing, our gear with the step side down, proper size pipe, and we should be good to press down at this point. There we go. So we got this in a safe place. Everything's pressed down. I will use the impact gun and just give it a little blast. When you think of the crimp that was on this nut, then when you tighten that down to its proper position, they should pretty much line up if you reuse the nut. Obviously you can't do that if you didn't reuse the nut. So at this point, I'm going to go ahead and put my puller back on here. I'm doing this for two purposes. One is I'm going back together with it, so I'm going to need to expand it open to get my belt in there. Another is that I want to lift up on this pulley sheave a little bit to help me get the snap ring in on top. So now that I've got the sheave pulled up, I can go ahead and put my belt on. And if you remember, I wanted to kind of remember the direction of this belt, so I put this tie strap on there. The tie strap's facing up like I left it. And I'm going to go ahead and slide this primary sheave into place. Once I have this primary sheave in position, I'm actually going to grab another zip tie, and I'm going to go around the whole belt assembly as a whole. What this is going to do is it's going to squeeze that belt together, and it's going to prevent this secondary sheave from squeezing together when I take my puller off. It'll come together a little bit, but not a lot. So I don't need to get carried away with that. I just kind of need to keep it tensioned like that. Look at it from the top. You can see it's just like almost like direct drive, it looks like. So at this point I can go ahead and take my puller off, and this should stay in that position. All right, so the benefit of that was that now when I go to put this end cover on, I got a little bit of wiggle room to move my sheaves in and out in relationship to each other. I'm going to go ahead and prop this up on some of those PVC pipes. Once I get this into the transmission housing, then I just cut my zip ties off, and that's good to go. Here I've got some of these bolts. They're just basically bolts with heads cut off on them. Pets with their heads cut off. Name it. Name that movie. Give you a hint. Jim Carrey. You gotta line these up. Okay, so we got these kind of guiding us down in there. I found that tapping it side to side like this seems to get those to drop in better. Also helps to do a visual real quick before you get carried away. Make sure things are aiming straight up and down. I've got a little rubber mat here to help me level things out a little bit better if I need to. Just in case you're off by a smidge. It's very important that this is all brought in there evenly, gently. Under no circumstance would you want to pull this together with the bolts. And the reason why is because these plates that are back here, they're stamped steel. They're not very tough, so you'll likely just bend the plates, and the transmission won't go together properly. So when you know you're there, when you go to tighten this down, and it it's a nice tight, firm stop. Kind of goes up. You can feel yourself squeezing the O-ring, and then it stops. So I went ahead and snugged these up. Everything's in there perfectly fine. Go and slide this off. And at this point, I need to cut my straps off there, my tie straps. Okay, I've got my tie straps off. And you can see I immediately went to low range. But it's being supported and held in properly. If this wasn't a lab unit, I'd make sure that's peened in there to make sure it won't ever come loose. Now before I assemble this any further, I have that ratio assembly, the mechanism that follows along with this primary pulley. I want to make sure I have it in place. That involves taking this guide, placing it down in there, push it down in there a little bit. You have to do that with the rod out. It slides underneath there, and then I can slide this rod in. So I can go ahead and take the case half and slide it on over the top of this assembly. Now if this was a live job, I'd want to make sure I'd have sealant on here. Use some anaerobic sealant, something along those lines. And I want to make sure everything is ready to go at this point so I don't have to take it back apart. So it's a good time to do a bench check, make sure that you're not forgetting anything. But really there's not that much else on here. Probably the most commonly forgot thing would be this pulley follower that lives on this side. I'm going to drop this case half on here, but it would be wise to double check to make sure that O-ring is there. It's going to seal off. It would suck to do all this and find out you forgot to put that O-ring in. Look down there to make sure your parking pawl is finding its way into the right spot. Then push the case the rest of the way down. Go ahead and take a couple bolts and put them in the other side of the case to hold it in place. Not a bad idea. If you had sealant on here, it'd be wise to flip it over and tighten and torque all of these. And this is just a live unit, so I don't have to do that. I'm just putting these bolts in to keep them from loosening up and falling out of position. Now I can go in and put the rest of this stuff back in. If you remember, this whole area here housed my reverse piston. So if I'm rebuilding this, I'd put a new piston in. And I will put my piston return spring in there. And on top of the piston return spring, I have this kind of stiffening plate. And if you notice, there's a little notch cut right there. And that actually goes in the 12 o'clock position. If you have to, rotate the piston around so it's centered. So this stiffening plate is centered over those springs, like that. And I'll go ahead and put my snap ring in. I won't be able to put the snap ring in without compressing this return spring assembly. This is a homemade special tool. It's nothing fancy. It's actually out of a 5R55 or 4R44, I don't remember. It's Ford A4LD, whatever. Center support, and I just cut little sections out so I can gain access to the snap ring openings. So if you got one of those laying around, otherwise you just need to find something to push down on that spring assembly to compress it a little bit. It probably only has to go down about 1/8 of an inch or so, and then once it's down, you can put the snap ring in there. So you just have to fabricate some kind of a cross that will push down on that spring assembly enough to get that snap ring in the groove. Crossbar and a C-clamp. At this point, I stack up my clutches. The first plate that goes in is this dished plate. And kind of like that stiffening plate, they've got a notch cut out at the 12 o'clock position. And then I go a normal steel plate. They don't put any notches on those. So I get to the top plate, which is a backing plate. It's thicker than the other steels. Then I put my thicker of those two snap rings. The snap ring that was down there is thinner. There's not much tension on those. It's pretty easy to install by hand. So now I'm ready to install my gear set. We do have a Torrington bearing that lives between the pulley assembly and the actual carrier assembly. And you can see there's a machine pocket in here, but it's not really designed to fit in the pocket. This inner race is designed to fit around the shaft. So we lay that in there like that. Put the sun gear off to the side. There we go, that's sitting down nicely. And then I've got a Torrington bearing on the sun gear. Now it is designed to fit into a machine pocket because it fits nice and snug with that. Drop it in. This is my forward clutch and my internal gear assembly, and we haven't taken that apart yet. So let's go ahead and see what this is all made up of. So while we're here, let's go ahead and take this apart. I've got the snap ring out. This is the internal gear. It's really nothing but just a simple internal gear. And there is a snap ring that it rests on right here. So if I look at these two snap rings, the top and the bottom, they're the same. So you really can't get that mixed up. And inside there I've got a dish plate, and the dish is facing down on this. Then I go steel friction, all the way up to the top. In order to get this piston assembly out, I'll need to compress this balance piston down a little bit and open up that snap ring. Here is the balance piston. There's not a seal on the inside edge. Any of the fluid that gets into this side is going to be able to find its way out through there. They do that on purpose. Here's the piston. I could just pop this on the bench to get it out. This is another molded type piston. So on an overhaul, we would just go through and replace this piston. It's just standard practice. No seal installers needed. When we go to install the balance piston, we want to make sure we're pressing down evenly so that that lip seal can kind of guide itself in there. There's a lip seal on the outer edge, but not on the inner edge. So kind of watch it. Make sure it's going down evenly. The piston that it fits into is kind of rolled on the inside, so it shouldn't have a problem. Just make sure the snap ring is on the inside of these little raised areas of the piston right there. I mean, that's what helps retain it so that stays in the position it's supposed to be at. Now you can go together with your friction and steels. You got your dish facing down, goes in first. Then your steel, friction, and alternate to the top plate. The reaction plate is a little bit thicker, just to be expected. That's what all the pressure pushes up against. We got our thicker snap ring at the bottom. Then we have a snap ring in the second groove down. That supports the ring gear, internal gear, whatever you like calling it. And then we have a snap ring in the groove above it. There we go, we're back assembled. You can air test the clutch by pumping air into that hole right there. You can see it apply. Now I'll keep going back together with the rest of this transmission. I can go ahead and put my forward clutch and internal gear assembly. I did have that Torrington bearing in there that would sit up against the surface. That's now sitting all the way down, nice and flat. Next comes my support assembly. Tapered rings are all good. The section with the oil feed holes, they're going to go across this section right here in the case. If this was sitting up at all and kind of turning, like it's not resting on something, that means I don't have everything all the way down. So I'm going to go ahead and put my bolts in here to hold down the center support. For the purpose of this video, I'm just going to go ahead and install this oil pump here. There's nothing wrong with it. I do have a separate video that I cover the operation of this oil pump and includes some information on like that flow control valve, which is a commonly worn out part. So before I put this in, I do need to make sure I've got my seal that lives under that. That seal fits down in this recess right there. And I can put my pump in. Got my Allen bolts there, but don't forget I also have this bolt with a little rubber O-ring seal that comes in from the back side underneath. While I'm here, and so I don't forget, I'm going to put my pin in there for the shift shaft. Remember, that goes right there. Then I'll go ahead and put my detent assembly right across here. At this point, I can go ahead and put some of this shrouding on there. Now I'm ready for my pump sprockets. Remember that identifying link needs to face up. I gotta put my little thrust washers there. That's for the drive gear. Okay, so slide this guy on there and that one on there. In order to get this in all the way, I have to expand that snap ring in there with my snap ring pliers. And they'll drop in there just like it's supposed to. At this point, I've got this, the majority of these components installed. I'm going to put my transfer gear in here, and I'm going to put my final drive. But then I'm going to do a bench check. It's always a good idea to stop when you get to a certain point like this, do a bench check to make sure that you're not leaving something out where it requires you to take everything back apart again to get to it. So I think I'm good to put this cover on at this point. I didn't see anything when I did my bench check to tell me otherwise. So once again, if this is a live job, I'd want to put a coating of sealant around this, probably some anaerobic, some high quality anaerobic sealant. And then I go through and put my bell housing on. So these shorter ones pretty much dominate most of these bolts. Every once in a while you find a longer one that has a little bit of a shoulder on it, or a unthreaded section. And you'll have 2 that go up on the top and then 3 that go in the bell. Okay, we've got our bell housing side done. Now I'm going to flip it over, finish putting the bolts in on our pulley side. You notice the input shaft spins free and smooth. Nothing's bound up. That's always a good sign. So we have the pulley cover, the bell housing, everything's assembled. We're at that point where we need to deal with the valve body. So before I go through and install the valve body, we're going to take it apart, inspect it. We're going to go through and make sure that the solenoids are good. We're going to make sure that the valves are all sealing properly. We can do a vacuum check on it. And we'll go through and do our inspection on it, make sure everything's good. Then we'll go through and install it. I'm going to go ahead and take this valve body apart in front of us. And I'm going to go and pull this ratio control valve out with its little spring, kind of get it out of the way. There's 3 layers to this valve body. This top layer right here includes the solenoids. Other than that ratio control valve, there's no other valves in this top body, but I do have to pull, I can either pull the solenoids out individually right now, or I can go ahead and just take all these bolts out from the other side and just separate all 3 halves. I think that's what I'm going to do for the sake of simplicity. These 2 right here that have a nut, they're little tighter holes, and they'll help align all 3 of those valve body halves up. So I can actually leave that on there, those 2 on there for the last bit. And then when I go to take it completely apart, those will be the last 2 I have to take apart. So it's always a good idea to go from the outside in when you loosen things and go from the inside out when you tighten things. The bolt heads pretty much stick out the same amount. And when you go back together with it, it's always a good idea to put all the bolts in there without tightening any one of them down, just to see if they all stick out about the same length. If one's sitting up a little higher than the others, then you know there's probably one sitting a little lower than the others. Now, as far as this top half of the valve body is concerned, once I take these 2 bolts out that have the nuts kind of clamping it together, I can pull this whole electronic valve body and put it off to the side. Yeah, we can look at and want to clean and all that kind of stuff. There's O-rings with all these different solenoids. I don't think we're going to go ahead and mess with those since we're just really going through and dealing with the valve body. Of course, if you suspect any of these solenoids, you can check the resistance of them, you can power them up, check airflow through them. Two of these solenoids are normally high solenoids, which means when they're off, they're passing fluid pressure to them. These two solenoids, this first one is the torque converter clutch lockup select, and the second one is the torque converter clutch control solenoid. So this determines how much apply force there is in the torque converter clutch. So these two solenoids are normally high solenoids. This one here is for the secondary pressure regulator, and this one's for line pressure regulator. Then we have our two pressure sensors. This first pressure sensor right here is a primary pressure sensor, so it checks the pressure in the primary pulley, and then this sensor right here checks the pressure in the secondary pulley. And then this is our stepper motor, and they basically have a set of windings in there, and they can pulse these windings, reverse polarity or positive polarity. Depending on the winding, they can move the stepper motor. It's like a thread. So they can thread it in and out, depending on the polarity and which coils they pulse. Tied in with this wiring harness going to these solenoids is this little black box right here. This is a ROM, read-only memory, and it lives with this valve body. It would come with this valve body and these solenoids. It contains the calibration for these different solenoids and kind of the flow rate of this valve body. But the vehicle also learns this ROM. When you hook the harness up to the vehicle, it's actually going to look at this ROM and like synchronize with it, and it's going to expect to see this. So if you swap transmissions without keeping the original vehicle's ROM in there, you're likely going to set a code, a mismatch code. So a lot of times, even if people are swapping out valve bodies, they'll make sure this ROM stays with the vehicle so they don't have to run into that. Now, obviously, if you're putting something new on, you could also reflash the computer and basically train it with the new information. So remember, this valve body has three halves. This top half is primarily the electrical stuff and the ratio control motor. Then we have the middle valve body and then the main valve body. There are 4 check balls, and there's a filter screen in there. So when we pull it apart, just kind of be aware in case things try to roll away on you, kind of like they just did there on me, almost. So this top one is, as I mentioned before, the solenoid valve body. In order to take these solenoids off, I have to take these bolts out here, and then they pry up basically from this plate. This plate that bolts down is actually like a lead plate. It's got prongs that accept these different solenoids. But I'm not going to take this apart. There's really nothing to show with this. I guess I could push air through them and energize the solenoids, but we're really going to focus primarily just on this valve body. And here are our 4 check balls. So I took this apart upside down, but those 4 check balls would normally live in these little spots right there. This check valve lives in this spot right here. And if you slide this valve body half apart while this is all together, it shoots out and almost takes your face off. It's just a piece of plastic and a spring. It's nothing major. On this middle valve body, when I flip it over and I take this separator plate off, you can see right here I have a little filter screen. So you don't want to forget that, forget where it goes. I'm going to lay all this stuff off to the side because I'm going to take these valve bodies apart, and that way we can do a vacuum check on them. There we have it. That wasn't so bad. I know Mr. Robert Bateman probably wouldn't approve of me slapping this thing on the bench, but hey, it gets them out and apart. If they fight you, don't stare at them like you're staring into the barrel of an open gun, like I did, almost got hit. All right, I'm going to identify these valves that we have here, and we'll clean this up, put it back together, and we'll do a vacuum check on this middle valve body. Okay, so this first valve lineup right here is the select control valve, and the second valve is the select switch valve. The third one down is the torque converter control valve, probably an important one. And then this one right here is the shift control valve, and this one on the bottom is the secondary valve. So I'll go ahead and put it back together real quick. Just got done cleaning it out. It's all spick and span. Sprayed some brake clean on it to make sure there's no false oil seal when we do a vacuum test. I can also kind of get a feel for how well these valves slide into the bore. These all slide in pretty good. If you notice on this end plug there, it's got a little centering device there for the spring. So you got to make sure that's going in towards the spring. Otherwise it really wouldn't serve a purpose. This first one that we're going to do here, or the solenoid regulator valve, should see 18 inches. 24, that one's pretty sound. This next one's part of the secondary pulley control. 16 inches, that's right at the spec. This is the torque converter clutch limit valve. About 17 inches there, so it's a little low, but my guess is that's probably pretty good. So this middle valve body tested out pretty good. I don't think we'd have to address any issues with this. And we're going to go ahead and take apart our main valve body. Okay, I've got my main valve body completely disassembled. Now I'm going to go ahead and identify these valves, give you an idea of what their purpose in life is. This is the obvious valve. This is our manual valve. It's what hooks up to the linkage. Next we've got the torque converter regulator valve. You can see here, it's probably an important one. This is our clutch regulator valve, the one with the hefty spring on it. And this next one is the pressure regulator valve. And then lastly, we've got the secondary pressure regulator valve. So pretty much all regulator valves in this one except for the manual valve. Now all I have to do is clean this main valve body up and get the oil out of it, reassemble it, then I can do a vacuum test on it. This first one here is the torque converter clutch limit. It's supposed to have 18 inches. And we got 23. This one here is part of the secondary pressure regulator circuit. Two spots we need to measure on it. Whoa. Two sections we need to measure on it. 23 inches. The instructions say when testing this port, prevent the end plug movement inboard by blocking the valve outboard. They want you to block this valve that way, otherwise when you put vacuum on there, it's going to suck that in. I don't really know if that's a big deal though. I mean, it's still checked out pretty good. We'll get 20 inches of vacuum anyway on it, so I'm not too worried about that. On this one here, this is also part of the secondary pressure regulator. I'm getting 16 inches. It says I should get 18. Then this right here is for the primary pressure regulator. Getting 23 inches there. That's pretty good. Well, I got this valve right there. I got 22 inches on it. That's the torque converter clutch limit valve, another limit valve. So torque converter clutch limit valve checked out pretty good. The primary checked out good. Secondary, this passage was a little low, and then this passage was pretty good. So all in all, I think this valve body's fine. So this valve body turned out pretty good. There was just a couple areas that might be suspect, but I don't really think there's anything wrong with this. So I'm going to go ahead and build this back together, and we'll go ahead and put it back in. The transmission should be good. All right, so I got the 2 bolts and nuts in there. It worked out nice. Next, I need to go ahead and put the rest of my valve body bolts in. If you remember, I said that I usually put all these in and then look. Then I look to see how high they're sticking out. Okay, so I will tighten these up, going from the center out in a spiral. Now I'll just apply my final torque. So I've got my valve body completely reassembled. It was tested, all came up pretty good. I'm gonna go ahead and slide my ratio control spring in there and my ratio control valve. This link right here, it's got kind of like a taper. That helps it find the pin when you go to install it. But we also use a piece of welding wire, slide it through this hole right here, and that keeps this in the approximate position. While the CVT is in low gear, the pin should be pretty much right around that spot. We're ready to put this baby on. I'm going to drop this in here, and before I do that, I want to make sure I have that little seal that lives in this recess right there. Goes in just like that. And I'll tuck my electrical connector down in there. I'll be able to fish it out. I need to direct this shifter shaft through this hole. And right now the hole's kind of big because we don't have the little bushing. There's a bushing that goes in there. Okay, this shift shaft, you can see it kind of flops around in there. There's a little sleeve that slides down in there. So you don't want to forget to put that in. While I'm here, I'm going to go ahead and put the manual valve lever there that lays across with its lock washer and its nut. Got my little bracket for my oil filter. I'm going to place the rest of the valve body bolts in there. Make sure there's an O-ring on the oil filter. Just kind of pop in there. So once again, it's good to look, before you tighten any one up, look to see if they're all sitting out about the same height. All right, I've got my transmission assembled. I just have to go through and put on some of these external things, like the pass-through connector here that I took off. It's got a fresh O-ring on there so it won't leak. We've got our oil cooler assembly. You'd want to put a new cooler in there. There's a rubber gasket that goes on the bottom and a fresh new O-ring. I also have my speed sensor. Maybe you remember, but this is a speed sensor that required some shims. I've got these 2 shims. They kind of just look like little washers, but they need to be put between, oh, almost dropped those in there, that'd be bad. They need to be put between the sensor and the case. You can imagine if I forgot to put those shims in there, it would probably push, I'm sure it would push the sensor into the gear that it reads off of, and it'd grind the tip of that sensor off, creating all kinds of metal and plastic. A huge mess in there. Not be good. Okay, right in here I've got my primary speed sensor. There is no shim on that one. We have our range sensor. And when we put the lever on for the range sensor, it has a little pin that would line up. Use the shank of a drill bit or something to line up this shift lever with the range sensor. And lastly, we don't want to forget to put our seal on the input shaft for the torque converter. All right, well, this one's done. Hopefully you understand how this CVT operates and some of the tricks on getting it apart and putting it back together. Really isn't that many special tools involved except for that one big puller assembly that we need. There are some kind of homemade, homespun versions of trying to get that apart. I'd probably recommend, if you're going to rebuild a CVT, to invest in one of those pullers. Transgo has a kit that instead of using that puller, you can use this clamp mechanism that goes around that, that movable sheave, and then you use just a standard puller to kind of pull up on it. It will do the job also, but if you find yourself going through CVTs frequently, you're probably going to want to get that puller like that TJ1 or something equivalent. Posi lock. All right, thanks for watching.